Apologies everyone. So I just lost internet for a bit and then now it's back. So let's do some stuff. So what I wanted to do is actually end up testing this device. We have this little device over here, this binary, how do I call it? SPI, I2C SPI bridge. But it also, this I2C SPI bridge also has a GPIO expansion port in it. So what I wanted to do was actually end up testing. I think that's wrong. Oh no, that's okay. So there is ground there, there is VDD there is 4 lines, purple. Yeah, cool. So what I wanted to do is end up testing whether this device works and see if I can get it to work properly. And I think I did have like some sample of how to run it. It was pool. This is one of those pools like I've just opened so many times. 88 something like that. SC18 bridge. Okay, so the first thing I want to do is binary to hex. Wait, this bridge, I want to know what its address is. Its I2C address. I think it's cross 28, if I'm not wrong. I think it's cross 28. Yeah. So yeah, here's the address. 0101 target addressing the first 7 bits or the first 7 bits of the first byte sent after the start conditions that define the target address of the device given of the device being accessed on the bus. The 8th bit determines the direction. So the A in 00 is so it's actually cool. So this is 01010000. Basically that's basically what that means, because I'm not setting them right now. These are the programmable parts of the address, and I'm not gonna do that. So I'm gonna do binary to hex, and I think it will come to cross 28. 01010000. Convert, this should come to cross 28. Yeah, so that's cross 28. And I want to Zephyr I2C. Zephyr I2C. I think it should be like something like I just want to see something, custom target, something like that, and I want to go see the code here. Hopefully it gives us an overlay that we can use. Yeah, I just want to see the way that, oh crap. So I wanted to see the way they're doing the registers, the way they're doing, I don't remember how to do this. I really do not remember how to do this. I2C target. I do not remember how to do this. I just want to know, I just need one hint, not just, yeah, cross 24. So reg cross 24. LPIC, that's it there, and then you can do that. Okay, cool. So I want to do that. That's what I want to do in my code here. So it's actually not here. So I wrote an overlay. For the Blinky application, and then I think I want to add, if I remember correctly, inside the thing itself. So I want to do like reg equals yeah, I guess outside. We could just go outside. Yeah. So here it's gonna be reg equals to what is it? So last 0 cross 28, and then this can be closed there, and then at here I want to do add to it. So that should be cool. So let's actually build that. That's what I'm doing. I'm gonna build. So I kind of, first of all, hi everyone. My name is Zach and I'm an open source software developer, and today I'm working on testing a PR for a GPIO extension port which is working by way of I2C. So you can send this, we have this little GPIO I2C to SPI bridge, and it's also got like three GPIOs that you can use as well. So I'm trying to add this thing into Zephyr so that I can use it later in another project. Yeah, this is what I'm trying to do, and I do have the link in the description will have some videos that I've had from before that I've worked on this driver. So yeah, it's nothing special, to be honest. Then we're just gonna do some testing and see where this one goes. Okay, cool. So let's build it. I just want to test and actually see that it builds properly and it actually activates that pin and it doesn't just crash. Then we're kind of happy with it. And I think I might need a kconfig, undefined reference to device TS. I really know how to do this now. In function main, undefined reference to device OTD device OTD 54. I think I need a kconfig if I'm not wrong. If I am not wrong, I need a kconfig. SC1818IS606. So let's see what happens here. No, not that. I want to see the kconfig SPI that. So this is the SPI that, and I probably need a. So this is the SPI. I'll remove the SPI part of the thing. That way we don't need an SPI extension here. So I think I need a kconfig for this one. I need a kconfig for the. Yeah, I see. Because using this sample, I do have a sample I want to use, SC118IM. This YAML over here. Well, let's look SC18IM. Yeah, let's just search it. No, however way we ended up here, I do not want to here. SC18IM. Kconfig that, but I kind of want it to be in yeah, so you see this one has a nice I2C that, and this is a UART one that you have to I2C that. But I have a feeling if we go look at the GPIO one, and this should be some code I've already added for myself, but I just want to make sure. If we go look at the GPIO one, we should have something here. Kconfig SC18IM. So there you go. So there's this GPIO this. So we want that. So if we go PF and we want to do SC18IS. So there's this GPIO kconfig one. This is, I think we want to do this GPIO this. This has a default, so that's fine. So we want to activate this GPIO config GPIO that. So let's go here, and then I want to go here, and I want to go like So config GPIO config GPIO equals GPIO SC18IS606, and then let's say yes, we'll stop with that, and then actually let's try and build it again and see if something is found. Might be the same error, might be a different one. Might explode, we'll see. That's getting rather close. So okay, cool. In function main, undefined reference to device odd 02. So let's actually see. What did I do wrong in main? So let's go src main, and then let's just, before we do this, let's just keep it at let 0 so that we just build it up and we can see if it's actually pulled in properly in the first place. It does get configured, it does get, main doesn't have to like set it up. Cool, so main sets it up, and I want to do cut build Zephyr dts, and then in here let's grab SC18IS. Let's do that. So SC18IS, it's compatible, the status is there. So I want to do -B5 -A -A5 -A5. That's fine. What? B. Okay, cool. So that's fine. It's in there. There's a status okay. It's set up here. It should be cool. There's a 128 there and everything. And then if I do in kconfig in config.ts itself, so cut build Zephyr, and then in here I want to do config Zephyr again. Or .config, and then I want to, in here I want to grab SC1 SC18, isn't it? As an XP GPIO, that one enabled and this one enabled, so they're both there. And if we do actually run this, so the one thing I've done already is I've done so this one's probably GPIO DT spec LED that's that LED 0. No, the DT alias is that. Okay, cool. I see why it doesn't want to, number one, I see why it doesn't want to do, but I think if you look in the driver here, as I was testing, I added a log here, say we are configuring pin that, just so it can just explode up and we can see stuff. I'm gonna put this thing in bootloader mode, we're gonna flash, and then we're gonna run it and see what happens. I don't have much time. I could have had more time. My internet got broken and I started 15 minutes late, so I really apologize. This one was supposed to be a fast one, and it was not. It's not. So it's here, yeah. West flash. Let's see. Oh, I need to put it in actual bootloader mode. West flash, and then I need to do a gifting, and then I need to go like picocon -B115200, and in here I want to go like dev tty scm0. That's so it's there, it's cool. And then I'm gonna put this guy over the other side, cool. And then I'm gonna just press this one, and it's actually doing the proper LED stuff, but I know I need to do like debug logs. I need to enable debug logs. I need to put up log level, quite a high log level. In here, and then in here I need to enable logging. Well, I could also just do print k, enable logging. I always forget how to do this. just set a like quite a config log, probably config log, yeah. So there's this. I need to do config log, and then I'm gonna say yes, and then I wanna see config log log level, config log level, config log level. Yeah, it's this one. Log level. Yeah, I don't want that. I don't need that. I need the one that goes into such kconfig, yeah. So let's see, config log level error. That should give us everything. That should give us all the logs. Log can just enable log, and then it should actually log. So let's build it. Let's build it and try again. Just go that, and then I'm gonna, while that's building, I'm gonna go into here, and I just want to get into the really. Actually, it should have actually done the thing. It's just was flash. Yeah. That's it. It's not giving me the thing I wanted to give me, so let's see if we can src. Do I need to import print k? As long as the kernel is there, and I can just use printf or print k. Okay. Instead of that, I just want to do control. So I want to go here and go like printf. Let's see if that actually does the thing we wanted to do. Let's build. And then we'll see. So here's the problem. It doesn't actually pull the thing itself. It doesn't do the thing I want it to do. So it doesn't pull this driver in, which is kind of worrying me. This feels like there's something it never runs this file. It never gets to configuring the pin. So actually, let's go back to the overlay and see how we name this thing. I think we named it myLED4. Alias is LED4 equals unmyLED4. LED4. Okay. And I want to go here. I want to go PV. I want to go into the source, into the main, and now I want to use LED4. Now let's see. This is now where the problem starts. Yeah, I might not. We'll see. Let's see how this goes. Gonna explode. Nah. Yeah, you see. Yeah, it didn't save. So, let's see. Has to explode. So, let's see. What is the problem? Undefined reference to device DTS odd 52. It's not a let's actually learn how to do that. Yeah, let's actually learn how to debug device DTS. Device DTS or I know I can find it somewhere. I know I can find it. So let's actually learn how to do that. That might be the. Ooh, I can also use device doctor or something of the sort, but I don't know. I don't know how to use device doctor yet. So I want a DTS odd something. From DT doctor. There's a device tree doctor. There's a new device doctor something where yeah, so this should probably tell us how to use it. West build. So do I want to do that? Yeah, okay, cool. Let's try that. Oh, yo, how about that? Okay, cool. I like device doctor. So if you didn't see, it kind of tells us that we need the following. But no, GPIO X SOC that is enabled, SCSC GPIO, but no driver appears to be available for it. Try enabling this. So I guess it needs all of them. It needs both of it needs let's see, config SPI SC1, because yeah, remember remember the remember this application we're building is a multifunctional device, so we do actually need to, it seems we do actually need to use both. The SPI driver actually brings in, the SPI driver actually brings in we use the SPI header basically. Let me I'll show you here. So first of all, there's this. So there's this SC18IS66. So there's that. There's no MFD for it. Okay, SC18. Let's go to GitHub and see if actually we can find something. This is actually cool. Device Doctor is quite cool. So that's nice. We can actually, in the meanwhile, why don't we build it and see actually yeah, well, let's use it that. Let's use it that and see. And while that's searching, let's go here and go see if we can find SC18IS IM704. And I want to find all the files that have this. 704. I want to find all the kconfig files as well. I2C. MFD, yeah. Bindings, yeah. Bindings, yeah. CMake list, yeah. Did we add it to CMake list yet? And GPIO kconfig, I2C kconfig, that's everywhere it is. So let's actually see what happens. Perfect. I have a feeling we have not added it to kconfig. So I would like to go to GitHub Gaucho here. But still, it doesn't track. Anyways, let's see what's happening here. So I wanna see the branch. Which branch do I wanna look at? I think the GPIO one. And now I see these 2 comments ahead. Why did I change? Yeah, 7 files change. CMake list. Library source GPIO that. If kconfig that, that's cool. Kconfig adds SC18IS606. Yeah, there you go. It adds that one. Depends on SPI's SC18IS606. Yeah. DD has that enabled. So I need to add it in. I see what's happening here. Yeah. So I do need this node somehow. Even though I'm not using it, I do need this node. There's this node over here. Do you see this node? I do need this node because it says I do need DT1, the DT1 over here. I mean, why would you use this without that? But anyways, for now, let's just enable it and see what happens. I see DT has this node. It depends on DT having this node. I'm very tempted to remove this requirement of DT. Depends on DT has that. Depends on that. That's fine. But depends on DT having that. I don't know that I want that. I don't know that I want to mix them up. Actually, I'll remove it just now so that this one I want to remove it actually. Yeah. Can I do this here? No. Can I do that? Okay, cool. And then I want to go that, and then I want to see. Let's use Device Doctor again and see if it actually does that. 161. This is different. This is different. This is probably gonna build now. Okay. Perfect. Perfect. Uh-huh. So there's that. It's enabled, but it appears there's no driver for it. So I want to remove this. It's fine. We need bindings. There's a binding that's missing. I don't see a binding file change. Oh, there's a DTS binding GPIO NXP that compatible that. YAML. There's that. There's that. NXP that. That's cool. Um, Because remember, kconfig does two things. Kconfig brings in code, and kconfig can be used to configure as well. It almost like brings in your thing, your driver, and it also can be used to configure it. So there's something here, NXP SE18IS606 GPIO. Yeah, but then what did I do here? What did I do here? Do I really need that device tree node? Do I really need this SPI driver? This one. Okay. And then do I want to just put this back and see what happens then? Just put it back and see what happens. Let's see what happens if we do that. Because I think it's very tied to the SPI driver, because we're using the SPI header. It's gonna explode. No driver appears to be available for it. So cool. So there's something somewhere I'm telling it to look for the wrong file or something like that. So let's go and look at the kconfig one first. If config GPIO SE18IS606, yes. So project config GPIO S18IS606, yes. Why is this longer? One letter longer because of that. Okay, cool. If that Zephyr library include drivers, Zephyr library source, GPIO S, I don't think that's a file name. It is here. GPIO SE18IS606-C. And driver compat NXP that. So I do have the compat. So there's something here. It says GPIX dot SE18IS606 is enabled, but no driver appears to be available for it. But git branch, we are on the correct branch, which that driver should exist. Why can you not find this? Same thing there. How come we cannot find this? SC18, SC18, let's look. SC18. GPIO, GPIO, SC118 RS 606 606. Let's see. There it is. It is there. That's where we're doing the print. This is the file. This is the file. You see, SC18606.c. And the driver compat, DT drive compat is that. NXP SC18 S606. Okay. Okay, cool. Let's look at the SPI one because the SPI one worked earlier. Why would you not find the driver? Why are you not finding the driver? What am I missing? Some CMake thing. This is like a CMake or a K. It's a CMake thing actually. CMake and kconfig. Somewhere in CMake and kconfig something is not agreeing. Yeah, because it wants the driver so it can use the header from the other side, and then kconfig goes that. Which exists by the way, which exists here. Which exists here. With kconfig, it's that SC18 IMIS 606. It's there. It's right there. Drivers GPIO kconfig. So drivers GPIO kconfig SC18 IS 606. Yeah, there's that. It depends on that. Depends on that. Depends on GPIO's IS 606. Yeah. Okay. So there's a compat here, NXP6. Somehow it's not finding this file. How did I mess up? How come the test can find it but the I have this driver. I have this file. The test can find it. Because look here. If I go Control R west twister. See, if I do this, it will find it and it will run it. The test can find it and they will run it successfully. Okay, there you go. Test drivers MFDO completed, 1 error. Ooh, yeah, let's fix that. Let us fix that. So let's do that. Let's less this file. Okay, it'll tell us what the issue is. Okay, cool. Implicit implicit declaration, and is that where the problem is? Okay, cool. So it turns out we're the ones that are breaking this thing. Printf. So log error. Okay, cool. See? Clear. Let's run that again. Let's run that test again. Okay, actually, wait. ls rm dash rf twister. Okay, cool. I don't like keeping that folder. This is on. That's fine. So it turns out we might be the ones who are shooting ourselves in the leg. All of them are done just fine. So it could be the printf that was wrong. So let's see if Twister found it now. Let's build it to device doctor. See what DT doctor and see what happens. It's almost been an hour. I'm gonna have to stop soon, but it might even actually just work now, and we're good. And that's good. This is an error. That's very odd. They're all on. I see. No, but it's fine. It's on. It is on. They're all on. Status okay. Status okay. I'd hate to stop, but why would I have to stop? I'm not sure what's happening here. Let's run it without. Okay, ref build, and then let's build it again. Let's see, just a blank build. I think that's what I do. I should only upload my debugging sessions onto YouTube. That's like the best. Just put up. Yeah, it's breaking again. Why did it do that? Try enabling that. I2C is going to the right place. SC18IS606 at 28, and it's enabled, but no driver appears to be enabled for it. To be available for it. Let's do it with that DT doctor and see what happens. Oh, wait, I saw something. Warning was assigned the value Y but got the no. Check this unsatisfied dependencies. SPI SC18 equals no. I added this. This is my code. Why is my code biting me? What are you gonna tell me? It depends on what? It depends on like. Wait, depends on what? No, this one is not in yet. Unsatisfied dependencies. Okay, so this is where the issue is. Let's actually go back to the code first of all, and let's see if we can do hi, and then we can let's use let 0. Yeah, let's build this and then we can see. Do I need to do west update perhaps? Cut version. Yeah, 4.3. Okay, cool. And then let's just build now. Actually, let's build all the way to device doctor and see. So that's cool. And define label no GPIO XT. That's fine. I know what the problem is. We just want to remove every mention of this. So let's build it with device doctor and see what happens there. I want to see. Okay, cool, fine. Now if we GPIO, okay, cool, is defined. We've assigned value yes. So let's Control E. Let's go back here, and then yeah, let's comment you out. Let's find out why the base one is not working first of all. Oh no, it built. You see warning? There you go, we found it. So it wants this, it wants to got config SPI equals yes. Okay, cool. So let's doctor. So no warnings now. So if it ever depends on that, we have to bring in SPI and we have to bring in the other thing as well. So cool. So this should work now. This should work now because we never got a warning and it's gonna build all the way, so that's fine. So now let's actually go back and enable this. And if we're going to output overlay, and we can actually end up enabling this, enable this, and then I want to go back here and also enable that. But then that's cool, so that's fine. Let's try and build it all. We should not get any warnings. Okay, cool, that's fine. We did not get a warning now, so we can go back and enable this guy. It's basically it. It's just basically following a tree of dependencies. Should be okay now. No warnings. Yeah, so you see here, there's no warnings. There's nothing. There's no warnings. It's just gonna. It should build all the way. And now you see 170. So we've added the libraries that were missing, and that should be okay. This should be really okay. So actually, let's put this in here, and see if that log error comes up. See if that log error comes up. See if that log error comes up now. Where's flash first of all, and then there's this, and then if we reboot this, it should actually just go in correctly. Yeah, it says initialize using controller that. Boom. Yeah. So we never configure anything because we never run the configuration. So that's working. That's working. And then if we just now go back into the main and try and use the LED 4 that we made here, LED 4. We try and build for this. We should actually get that log now, because now it should work. It should work all the way now. So okay, so the problem ended up being we were missing the SPI driver needed SPI, and because the SPI driver needed SPI, our GPIO driver needed the former driver to get XPI, and then the former driver was failing, so that our GPIO driver wasn't getting activated. So with this, we should actually get something going. I'm just hopefully looking forward to getting that error that says, if we get that error that says pin 0 is being configured, then I think it's working. Where's flash? Okay, cool. And luckily enough, on the other side, it actually just initializes okay completely, so that's fine. Yeah, we are configuring pin 0. It basically works. Makes it work. That's it. It works. So this error was added. We added this error. We added this error. We added this error here. This is just so that we know we're getting here, and so that we actually get the correct one. And then it does say data pin conf. And pin conf we get from somewhere in the so it's active low. What should it be? Let's look at what it should be, and then we'll know whether we're done. So this is cool. It should be pin configuration here, GPIO configuration. GPIO configuration, GPIO config, GPIO idle mode, GPIO write, GPIO enable, GPIO configuration here. So it should be not input only, it should be push pull, because it's not open drain. It's push pull. It's 0 1 or 1 1. So this should be 1 0 1 1. This should be, if we do 02 02 02 02x. And this, okay, so pin, we can say pin should be, and then conf should be that, and then in here we can just pass in the pin conf. So because we're leveraging most of Zephyr drivers, this should just work by itself here. Let's see. So we should get, it's not open drain, because it's not just out. It could be open drain, but I think it's going to be push pull. But it could be open drain because we're like turning it off. We're turning the power on, the power off, power on, power off, power on, power off. So it's going to either be 1 0 or 1 1. That's basically it. And if it's that way, then I think we're done. We're set up. We're really set up correctly. I can also hook it up to I should be able to hook up an LED to this, and we should be able to get something. But let's actually do another West flash. Okay, cool, that's it. And I want to be on this side, so I can go that. Yeah, 0 1. Yeah, it really does work. So let me see if I can find an LED. Some sort of LED. And we can actually tell. Control LED here. Okay. Let me find an LED and we can try and blink it or something. So we have two females and two females. that one? Where did I put the LED? I had an okay, yeah, here it is. So the thing we want to do is we want to connect the LED to the how do I say it? So this the cathode and the anode of the LED. So there's that. White one's gonna go to ground. We have a ground there. Yeah, we do have a ground. So there's a ground there. White one is ground. And then SS0 is yeah. So we can. So there's that. So here's a LED. I mean the connection is not so stable, so that's why it's keeps going off and on like that. It doesn't really go off as I expected. Here's the LED. But yeah. There we go. There we go. There we go. It's actually working. So it's not working the way I want it to work, so let's see. Active flow. So there's some sort of problem. There is some sort of problem because it's I think it's in. It should be being set and being off, or there's some callback here that we're not directing properly. So there is some sort of little problem because it's not going off and on. So I want to see what callbacks we provided here. So set row. Yeah, get row. Get row. Okay. Set mask row. Set mask row. Set bits row. Set bits row. Clear bits row. Clear bits row. Port toggle bits. Okay, cool. So yeah, let's actually look at this driver. This other driver. SU1, the GPIO driver for it. It's gonna be I think it's gonna be a very simple thing that we've missed. Or maybe we're not writing or something. So get row is a ISP transfer that. It could be working. It really could be working. I might need I'm gonna see if I have logic analyzer. Should have logic analyzer. This is the problem with using microcontrollers for everything. Even my logic analyzer is another tiny microcontroller that I don't know where it is right now. So I can't see it right now. So I need something to look at this pin. I need something to observe this pin and let me know if it's actually flipping on and off. I'm looking for my logic analyzer, please. Excuse me. The problem with my logic analyzer is that it looks looks exactly like a microcontroller. Yes. It is based on a microcontroller, and I might have ended up keeping it as a microcontroller somewhere. So it's probably right in front of me, and I'm missing it because I'm looking for a logic analyzer, and it's actually a microcontroller. Come on, Zach. It looks exactly like a dev board, so don't rush. Don't rush. Yeah, there it is. So this is my logic analyzer, and it does use USB-C. I do have USB-C connected, yeah. So I'm gonna hook this up. The white one goes to ground or 0. So I can probe 0 and 1 and see what happens. And maybe they're just flipping so fast that I can't see. Yeah. So cool. Sorry about that. What I'm gonna do here is I'm gonna run pulse view quickly. Pulse view. Pulse. Sigrock. Do I not have pulse view? Do I really not have pulse view? I should have pulse view somewhere, man. I should have it somewhere. No, install Sigrock. I thought I had pulse view on this machine for sure. Sorry about that. Demo device, no. I just want to connect to a device. Scan for devices. No, it's gonna be the generic ones, I think. Scan for devices, scan for devices. I don't understand. Is there like a React one? Should be there. Okay, so just unhook it up. Connect it. Connect to device. USB. No. Generic one. Scan. Yeah. That's what I want. And I just want to run it. Okay, so you see data 1 is always on. So that's not good. Data 1 is always on, and that's not good. That's the one that we want it to be fixed. It should go on and off. So there is some sort of setting here that is not going correctly. But this is going nice. So configuration is working okay. Set row and set row is basically what we don't know. Can we just log out what output state is here? Log error output state. Where's output state coming from? So let's look here. Output state is, and we saw it was 0, 1, which was open drain. Okay, so data output state. Yeah, we can remove that. We can close that. So let's build it again. We're so close. Anyways, the driver works. It drives the end device. It's just the toggling that we don't know what's happening. And the toggle might also be wrong. Because toggle, we do have some toggle bits. I think it could be one of these functions we've gotten wrong, actually, to be honest. Because this is a setter. Anyways, let's see what the setter does first of all. And then after we see what the setter does, we should be able to decide. This is gonna be like one of those 3 lines are messed up somewhere or something. West flush. Okay. Put it back. Let's go back here. Output state is 1, output state is 0, output state is 1, output state is 0, output state is 1, output state is 0. That's good. That's good. Run again. Yeah, so it never, something is going wrong. So there's output state is 1, output state is 0. Somewhere here we're messing up. Why is it not giving us a log error? Is it because we want a new line or something? And okay, so first of all, it's going well. That the set row is doing the correct thing. Why all these 3? What is a mask? Okay. That's fine. So let's, I don't know why all this 3, because right now, because we are writing to the whole port set row, so we need to use the mask. So let's come here. Let's see what buff 1 is now. Buff 1. Okay. It's gonna be somewhere in here we're doing something wrong. So this one's gonna remain, it's gonna be the same completely all the time. And if indeed it's that, then we have found our issue. So let's build again. Put this thing in bootloader mode. West flash. So I want to see what happens there. And then let's put this thing back into the normal one. Yeah. So let's go here. Let's say here buff 1 is. So let's do that. Excuse me a little. I need to quickly. Okay. I'm almost having it, so I just want to rush through the loop, but I almost have it, so I might as well finish because it's very easily finishable. So let's know if it's working on buff 1. Let's debug. Let's go back to the bootloader mode. Oh, I'm mighty glad that it's mostly working. I thought it would be that bit of logic there that would be the problem. Buff 1 is 0, buff 1 is 1, buff 1 is 0, buff 1 is 1. Buff 1 is 0, buff 1 is 1. Buff 1 is 0, buff 1 is 1. Oh, I know the other problem. Why this is actually if I'm not wrong, it's gonna be in here and it's gonna be down here, and then this is going to be, yeah, there is an N there. So I don't know why that's like that, but it's fine for now. Okay, so maybe it's not in here. So really maybe it's not in here. So maybe this is not where the issue is. So maybe this is not where the issue is. Okay, so let's look at so GPIO write. GPIO write 0 cross F4. It's gonna be something. It's somewhere we're doing some sort of like very small minute error. GPIO right, GPIO right, FOH, yeah, that's fine. And then this whole data is supposed to be 3 bits. Print binary. Let's see. No, I don't want to do that. I'll just print H. Let's just print hex. Let's print hex. Let's print hex. It's 0 cross 8. 0 cross 8. Yeah, we can just print 0 cross 0, 0 cross 0, 2, 0 cross 0, 2. How many do we want? How many bits do we want? I want x is hex string. X string, hex. I just want if I could get 8 characters in hexadecimal. Okay, let's try cross X. So what I want to do is see if I can print out this whole buffer. Not the whole buffer actually. There's something wrong. So the buffer, the first character of the buffer is fine. No. Check, man, this is not working correct. So it should be just one character of the buffer, because the buffer is a unit 8 buffer. So this should be 8 bits. I'm thinking here. So buff 1 should be 8 bits. So which doesn't make it should be 1 at the end or not, which is fine. When it's 1 0 1 0 1 0, it's okay. The issue is, why is this thing going in the wrong mode? It's just going on. And I think we did do a config. One, two, three, 4. 1 2 3 4. I'm trying to find out why. It's not in here. It's going to be somewhere, it's either the mode, input 00. So let's look at the mode. Let's look at the mode. Input configure. Input 00. Okay. Push pull 01. Okay. Input only 10. Open there in 0311. Okay. Conf mask. Do we ever use the mask? So where's the mask here coming from? But even if it's a mask, it's not actually doing the right thing, because it's right, F4H, yes. Enable F6H, yeah, those seem to be doing just fine. There's some toggling that we're missing somewhere between our driver and the actual device, because this shouldn't be this way, this should not be this way. If I run it, this should not be high all the time. D1 should not be high. D0 is connected to ground. D1 should not be high. Yes, D1 should not be high all the time. Wait. D0 is connected to ground, yeah. Yeah. So D1 should not be high or floating all the time. These other ones are floating. Why? Because you go and you write the configuration, you go and you write, yeah, so here is SS1, SS0, SS1, SS0, so you write it, you times 2. We should shift it left by 2 somehow. Yeah. No, I want to look at configure. Yeah. Because if it's 1, you shift times 2, you shift it to 2, but it should be ideally, you shouldn't shift it to 2, you should shift it to, I see where I found the issue. So you see, if you're configuring 1, you should times, if you're configuring 0, you should times 2 plus 1. If you're configuring 1, it's times 2 plus 1. If you're configuring 3, it's times 2. No, 2, it's times 2 plus 1. So here, yeah, I see. So here, shifted by this, plus 1. Times, because if it's 0 times 2, it will be 0. But if you plus 1, it's going to be okay. Yes, but if you plus 1, it's going to be okay. And if it's 1, you times 2, it is 2 plus 1, it becomes 3. So that becomes the actual thing that you're setting from 1 1 1 0 1 1 1 0. Okay, guys, just give me one moment. Let me quickly do a loop and then I'll come back. I'm back now. Sorry for the audio. I think the configuration location was wrong. So, and if I think it will go here, and we run it. No, that's not good. That's still not good. Still not good. Let me see. The int 8 t conf pose equals bin. So let's do bin times 2 plus 1. And then in here, what we want to do is actually do this conf pose. And then in here, we want to do log r, configuring position conforce d conforce should be good now. Should work. Already should work. So there's some slight issue somewhere then. Maybe these ones. Maybe these ones. So let's look at the other ones. But there's no issue here, because when we look at the actually set row, it gets cold. It gets cold with this. So configure goes to pin configure, get row goes to get row, set mask row goes to set mask row, set bits row goes to set bits row, clear bits row goes to clear bits row, toggle bits goes to toggle bits. So we just need to make sure these ones are calling the right ones. Yeah, I think let's make sure of that. But it still would have been working because it was being set up quite correctly. Let me look at this. Read 5, enable that, configure 7. So let's look at that. Let's look at those addresses and make sure they're going configure 7. So you write to that. Okay, I think I'm gonna stop there today. I'm gonna come back and make sure this thing works properly, but I don't know where surely the data going out seems to be completely fine, because it's toggling. It's going 00 010101. F7 is the one, 0 cross F7, GPIO conf, GPIO conf. Okay, hey guys, I'm gonna have to stop there today. Thank you so much. Let me debug this and I'll find out where it's not working. As always, I bid you to always push hard and be daring. Thank you so much.